In the last video, we saw how to compute pressure drop due to frictional loss in pipes and annuli. For laminar flow, we use we compute closed form analytical solutions. For turbulent flow, we compute this frictional loss by using some empirical correlations for both Newtonian and non-Newtonian fluid. So in this video, we're going to see how to compute a pressure drop in surface connections between the drill from the mud pump to the drill pipe. So there are some surface connections like standpipe, rotary hose, swivel, and Kelly. So these are some of the special equipments with different complicated geometry. So there are some empirical correlations developed by the industrial standard people, like equation 4.55. So it depends upon the flow rate, viscosity property, and the density, and E is something like an empirical correlation coefficient or constant, and which could be computed from the figure 4.10. So for different settings for standpipe, rotary hose, swivel, and Kelly for their geometrical configurations, we can have a different setup of E values. But there are other way to compute instead of using 4.5. There are other way like considering all these complicated settings, you can consider converting into an equal length of drill pipe. So once that drill pipe for a fixed geometrical configuration is been estimated, then we can use the equations like what we utilized in the last video for laminar or turbulent, for Newtonian and non-Newtonian, that 4.45, I think, those kind of frictional pressure drop which is related to the mean velocity for either a linear relationship or non-linear relationship for the turbulent flow, similar to the Bingham plastic and the power law model for the non-Newtonian fluid. So here comes a very important topic: how to compute a pressure drop across a drill bit. Drill bit is a very important component because it determines how the penetration takes place and the efficiency of the drilling operations. So one of the essential component is how the flow, the drilling mud flow through across the drill bit. Because there is a critical, the reason for it is a critical component here. It's where that pressure energy is converted into a kinetic energy that gives a high impact force, which helps in increasing the penetration rate and also helps in effective cutting transport from the bottom of the borewell. So that these things happens and are very related and sensitivity to the nozzle, because that is the equipment which has been embedded in the drill bit and where the flow happens through these nozzles. So when the flow through nozzles, we know that there's a convergent or divergent flow, then that pressure energy is converted into kinetic energy, which helps to increase the velocities so that it has a high impact force and the effective hole cleaning. So the pressure drop across the drill bit can be empirically computed using this formula, and CD is similar to the last thing. It's like an empirical correlation constants, and which has some standardized values. It's almost like it can be computed through the chart, but almost for this drilling mud operations, people have identified that commonly use 0.95. And then mu Vn is a nozzle velocity, and this is a geometrical configurations, and area of that effective area of the flow through cross sectional area, and that computed through that flow rate and the effective velocity. That effective velocity is also been computed through this pressure drop and the that empirical constant, and this is the nozzle's diameter, which is computed from the effective flow area. So through this we can able to compute the pressure drop across the drill bit. So this is about initiating a circulations, because for our last video we didn't consider about an important thing that there are for non-Newtonian fluid like Bingham plastic or power law, which if it is a thixotropic fluid, then it requires certain structural arrangements for initiating a circulation. For that structural arrangement, we need to have some kind of a pressure buildup, which is computed as a pressure drop. So that is proportional to the gel strength, and that gel strength is related to the thixotropic property of that particular non-Newtonian fluid. So higher the gel strength, the higher the pressure drop initially it requires for the initiating that circulations. For pipe, this is based on that geometrical property, and this is for the annulus, based on the geometrical properties on the gel strength. So optimization, as I mentioned in the last sections, like 4.7, flow through a drill bit is very important component for an effective drilling operation, because this is where it determines how the jet impact force helps to increase the penetration rates and the effective hole cleaning, and takes the cuttings from the bottom of the hole through the annuli and to the surface. So this drill bit hydraulical optimization depends upon many things, on like how that hydraulics happening, how that conversion of the pressure energy to kinetic energy happen, and also depends upon the mud rheology, and also mud density. So, what is the max? What is the pressure it requires for an effective hole cleaning? So let us have that pressure maximum pressure is like how the pressure drop across other equipments, and how the pressure drop across the drill bit. So this is the pressure drop across other equipment, like pipe, annulus, drill bit collar along the annulus. So once this been segregated as and del PFD, then we can compute the optimal drill bit pressure drop for that particular once the optimal pressure drop across these other equipments are computed, and we have the maximum pressure, given the maximum pressure, then we can compute the optimal pressure drop across the drill bit. So it has a two empirical formulae, either based on the hydraulic horsepower or based on the jet impact force. 4.6 force based on the hydraulic horsepower, it has some empirical correlation called AM. And also, if it is if it has to computer based on the jet impact force, then the empirical correlations is end up in 4.65. So M is some kind of an and that are again an empirical constant. Usually for industrial standard it's around 1.75, but it can also be computed through some kind of a flow chart. Then once that optimal pressure drop is computed, then we can use the earlier equations that we have shown to compute effective flow rate, optimal flow cross sectional area. Once the optimal cross sectional area has been computed, then we can compute optimal drill bit nozzle size. And once the nozzle size is computed, then we can compute the effective jet impact force or the hydraulic horsepower required. This is another important thing, like it is related to the drill bit hydraulics. How effectively the jet impact force uh, is being done at the bottom of the hole, so that the cuttings and drill and the bottom of the hole used due to the drill bit is being taken out and into the annulus. Once it's taken into the annulus, then there is velocity between there is like a differential velocity between the that cuttings particles and also the drilling mud. So this relative velocity will determine how the effective hole cleaning are. So once the particle moved into that annulus, it keeps flow along with the annulus, but the velocity with the cutting particles would a bit different from the velocity of the annulus drill mud in the annulus. So the velocity of the cutting while moving in annulus is called a particle slip velocity, and it is being computed based on two empirical correlation. One is on Morse correlations, which is being given by 4.72, and another one is related to the Chiang's correlations, which is again based on the empirical correlations and computed by equation 4.78. So this cutting slip velocity once been computed based on this 4.72, because most correlations have different different form different equations to compute a slip velocity based on the Reynolds number. So it's almost same, but once the Reynolds number increases, it becomes more like kind of a nonlinearity with respect to the rheological properties. So once this slip velocity is being computed, then what you are going to do is that the difference between that mean annulus velocity and the slip velocity is termed to be as a transportation velocity. That the differential things, that transportation velocity is being putting into this ratio called the ratio between that transport velocity and that mud annulus velocities. So this ratio, this value is going to determine how effective the whole cleaning is. So if there is some kind of if, for example, if this determines the cutting transport to be the transfer and ft is positive, then it's going to be if it is an ft is positive, then it's a good factor that it transport to the surface very effectively. But if the ft is not positive, it's a very low value, then it has a high chance to come back to the bottom of the hole due to the uh, gravitational